Okay, thank you very much. I think I'll start this talk by telling you a little bit about myself and my history, and that helps motivate what I'm doing right now. I said I would date myself, so here we go. I started in computers back around 1977. This is not a photo of my computer, but it is very, very close to it. This is something I found online. The only difference is that I had rocker switches at the bottom and the buttons were in a different place. But this is what my first computer looked like. 1978, I think, is when I finished that and got it working. And this is an RCA 1802, what's called the Cosmac ELF, and it had 256 bytes of memory. So a quarter of a kilobyte of memory. And that was my first computer. And that's where I first started doing programming. And to be honest, it was a whole lot of fun. I managed to upgrade that system to a much more sophisticated at the time system. Now, this actually is a photograph of my computer. And this would have been probably late 70s or early 1980s. It had 8.25 kilobytes of memory. I wired it my own ASCII keyboard and my own hex keypad. And the screen there shows a 64 by 64 bit or pixel black and white screen where I had a game running that I had written. So I was having a lot of fun with this computer, and I was just amazed at the number of things I could do with it. So over the years, I got into some different things. I don't know if anybody here has heard of a program that I wrote called DKB Trace or Pavre, but I got into ray tracing. This was done on an Amiga computer. Now, these days, the resolution looks crappy, but on the Amiga, it was pretty darn impressive. This is 2 dice floating in midair above a wooden floor. This was done in the program that I wrote called DKB Trace. And so I'll show you just a couple other pictures from that. This is a pencil. And then a friend of mine at Carleton University rendered this, which is Roman columns with a marble texture. So I was getting into all sorts of graphic stuff like that. I released DKB Trace as freeware because I felt that I was finished with playing with it and I wanted other people to enjoy that. And that's always been a big motivation of mine, is to encourage other people to enjoy the things that I enjoyed. Well, DKB Trace actually started to become quite popular, and I was getting requests to make changes to it quite quickly. And I was going back to university. So I said, tell you what, there's a group on CompuServe that wanted to make all these changes, and they were talking about writing a new ray tracer from scratch. So I said, tell you what, why don't you use DKB Trace as the base? You can, I will hand over all rights to you. And so long as you keep it open source and portable across platforms, then you can continue to develop it. And I actually helped them along for the next 3 years or so. These are some pictures that were created with Pavre. This one was actually rendered on the International Space Station by Mark Shuttleworth. He brought his own computer up as a space tourist to the International Space Station, rendered this on the space station and brought it back, and people made posters of it. This is Pavre. I believe it's done primarily with triangles, believe it or not. So you can imagine the amount of modeling people did to get this, but it's a pretty impressive picture. Ray tracing is really good at reflections. So you can see reflections within reflections, and they're all mathematically accurate. These are some fairly recent pictures, corkscrews, and you can see the kind of realism people are going for these days with this program. Now, I've been out of ray tracing for many years now, but I still follow along and see what people are doing with it. And I'm still shocked at the quality of the work. This particular picture is rendered at about, I think it's something like 8,000 by something. And if you can see those swans back there, I'm just going to zoom in on them. And you can see how it keeps the resolution high until I get to about that stage. That's how detailed this picture is. All of these pictures were rendered pixel by pixel. Ray tracing works by rendering one pixel at a time from the top left to the bottom right of the screen. So this was the kind of thing that I developed on my own, and then other people picked up and had some fun with, which is something I really enjoy encouraging. So over time, I worked on a few other things. One thing was a program called Elastilab, which I will show you right here. This was a product which I was trying to sell. And it allows you to create particles that are linked with springs and elastics. And in real time, it will simulate the physics behind the particles. And in real time, I can, let's say, take a barrier and drop it right down here, and it hits the barrier. And the nice thing about this system, and I'll show you an example, discard these changes. I am going to choose flying trapeze lesson. Now, this was meant for screens from like long ago, so it's meant for the screen about this size. But I'll show you this. This is a script that you can write, and there's a whole editor for it. When an event happens, then perform some action. So when the when the L key is pressed, delete the objects that have the name right elastic. And when the timer reaches 96, then delete this object. And when the K is pressed, do that. And so you can specify what to do when things happen. So in this case, K means swing, L means let go. I'll try it. I'll watch the expert first. They're trying to land on the trapeze. Okay, or on the, they're trying to land on the net there at the bottom. So I'm going to try it. K, 1, 2, 3, and then let go. And I'm going to fall off. I fell off. But this is the kind of game that you could develop with Elastilab using simulated physics. Interestingly, at one point, I was at a Smalltalk conference, and Alan Kay was giving the keynote address. And after the keynote address, I had a few moments to talk to him. And I said, I've developed a program that simulates physics so that kids can play in a world with simulated physics. And Alan says, well, does it allow them to change the laws of physics? And I said, well, no, not precisely. Okay, well, does it allow them to enter their own laws of physics? And I said, no, not precisely. Well, then that's the worst thing you could possibly do. So that was my endorsement from Alan Kay. And he has a point that not necessarily with Elastilab, because it wasn't meant to do that, but there is some attraction to allowing the kids to explore as much as they wish without restriction in the environment. And I like the idea of having everything open to you and you go as far as you wish to go in it. So that's one thing that I like. And then more recently, I wanted to develop Android and iOS games. So hold on here, I have to get this going. I developed a game called Sea Turtle Rescue, and I'll bring it over here. This actually ran on Android and iOS devices. and was released to the Play Store and the App Store. I never actually made any money from it, or nothing significant, but it showed that I could do this. This was written in Smalltalk, and I'll talk about that in a minute. It had little help screens to show you like how things work in the game. And the challenge was to line up numbers sequentially from where the egg is down to a 1 to give a path for a sea turtle to fall to the ground, to hatch, and to be swept out into the ocean. And then you go on to the next level. So I'll just try one more level. I'll go this way and then that way. And there's my turtle. And he gets washed away into the ocean. And this game had many series. Each of them had many levels, all pre-programmed with games that you could play, and the arrangements of tiles that you had to solve. So that's Sea Turtle Rescue. For this, in order to run it on Android and iOS, I needed to have a Smalltalk virtual machine that was interpreted, because iOS had rules, at least at the time, I'm not sure if they've changed, that prevents you from dynamically compiling any code. So I actually wrote from scratch my own Smalltalk virtual machine and my own Smalltalk image. And the code that was released to the App Store and the Play Store was all Smalltalk code that I wrote myself. I didn't have any other code from any Smalltalk environment in there. That was all my own code. Now, after I finished that, I thought, I have this nice Smalltalk interpreter, but what can I do with that? And I decided that I was going to start on a project to make this an open source Smalltalk that was available to people. And what I'd like to do is to encourage people, especially younger people, kids and young adults, to explore programming and have fun with the programming the way I had fun when I started in computing. So I wanted to do things that would help people get interested in computing. So after developing that Sea Turtle Rescue game, I had this virtual machine and this image that I could run and develop. And it worked on iOS and Android, but it wasn't something that would work on any platform. And in fact, for what I wanted to do, iOS and Android weren't actually the ideal targets. So I started to work on the Smalltalk. I simplified the whole bytecode set down. I re-implemented blocks. I wrote a new framework for a recursive descent parser and code generator. So now I have a system that can run, it's written strictly in C, at least the virtual machine is. And I have a WebSocket interface, which means that I can use a web browser as my user interface. I can render onto an HTML canvas. Oops, sorry, an HTML canvas. And I wrote a little bit of JavaScript that helps do some of the work. The JavaScript understands about components, which are rectangular regions of the screen. And it knows which component is on top and which component is underneath. And it can update one component without touching the others. So I'll show you how that works in just a sec. Let me pull it up here. So this is, I'm running right now on Windows. This is Cygwin for Windows. I have to do Beagle Smalltalk.im. And now the virtual machine is running, and the image is running on my workstation, on my Windows system. And I can pull up a web browser. And as soon as I pull this up, it connects to the image using WebSockets. And now I have a read-eval print loop here. 3 plus 4, print it. So there's the answer, 7. So I can type any Smalltalk expression into here. 9 squared plus 8. Print it, 89. The way I develop is a bit painful, but I have a folder. Let me pull it up here. Home data. Now this is work in progress, okay? So this is not ready for prime time, and I'm not ready to hand out anything just yet. But in here, I have Smalltalk source files, and I can come in and I can make a change, let's say Smalltalk system. I can edit this file. This is just a chunk format file. I can make the changes that I need to, and then from my command line, I can say st source, quote, st source slash whatever as file name, file in. And I file it in, and then I can save the image. The image has a generation scavenging garbage collector, and it also has a mark and sweep compacting garbage collector. And I'll talk about those in a few minutes. In addition to that, let me show you how the canvas down here works. So I will get this up. Excuse me for a moment. I'll just get this set up. Desktop. So I will copy some text into here. This is just a string with some, this is actually JSON format. And when I give this to my JavaScript, to my Smalltalk, and I say render it, it tells JavaScript to interpret this, and JavaScript will do that. So this is a window that says this is a very long string to render, blah, blah, blah. I'm checking that it's clipping to the edge of the window. In this one, I'm doing a Bezier curve. And JavaScript is basically just interpreting each of these commands in order to render into that region. Oh, and you can see as I move my cursor, I'm getting mouse move events. Those are being sent to the Smalltalk, and then Smalltalk is echoing the mouse moves to the window down here. So Smalltalk is actually receiving those mouse moves. Once I have that, I'll take this. Now, the window underneath is called window 1. So if I say window 1 and bring it to the top, render it. Oops, I must have gotten the name wrong. Hold on. Oh, that's push to back. It's bring to front is what I want. I'll just copy that. Paste, render it. So now that window comes to the top. I don't have to resend the contents of the window because JavaScript remembers what's in that window. All I have to do is tell it to bring that window to the front. And so in theory, I can draw anything I want in here. And I've started developing a little bit of a window system. So this is some Smalltalk code to create a new window. I'm putting it at this location, making it this large, setting the title to be this, and then do it. And there's a new window. I haven't yet interfaced to the drag bars or put close buttons into it or anything like that. But I can put my own windows into here. And at least currently, I can move those windows around with Smalltalk code. But ultimately, I'm planning to have a more complete window environment here where I can actually drag windows around and interact with them. And then the whole user interface would work in this canvas. And I wouldn't have a Smalltalk evaluator separately. If I wanted a Smalltalk evaluator, I'd just open up a workspace and type it into the workspace. So this is an intermediate step. But that's what it's doing right now. So let me go back to the presentation for a moment. This has a VM that's written completely in C. On the right side, you can see a list of the C files for the VM and the size of them. They are tiny. I showed this once to Elliot Miranda and he was, oh, it's so small, he says. It warms my heart that people are doing this kind of work. So I was happy with that comment. It interprets the bytecode, so there's no just-in-time compiling at all. It just creates the bytecodes and it interprets bytecodes. The bytecodes are ones that I put together myself. So I'm not using any existing bytecode set from any other dialect of Smalltalk. 7,800 lines of code. So that's pretty small. And this runs right now on Windows, on Linux. I'm pretty sure I could easily run it on Mac, although I don't have a Mac right now that I could try it on. It does run on Raspberry Pis, and it does run, believe it or not, in WebAssembly. So you can actually get this thing to run in a directly in the web browser. Let me give you a quick demo of that. I'll just do a command prompt. So this is Emscripten, and I'll just get set up with an Emscripten environment. Emscripten is an environment that lets you compile C code to run on WebAssembly. And so here I'm going to start a Python web server, just because it's convenient. So Python is now serving files on port 8000. And I'm going to open up my Chrome browser and go to localhost 8000. There's WAVM, and there's my Smalltalk. This now is running the VM and the image in the browser. And it doesn't translate to JavaScript, it translates to WebAssembly, and it runs the WebAssembly. I have done some experiments with this. It is possible to call from this out to JavaScript. And so I can call any JavaScript function from Smalltalk. And it's possible to call in, so JavaScript can call into Smalltalk and run Smalltalk code and then return to JavaScript. So it gives us some possibilities of running this way. I'm not going to show too much here, but this is basically the same thing as what I showed with the Sigwin version, except I don't have my canvas down below. That wasn't part of this particular test. So I'm just going to stop that. So I was quite surprised that I could actually run this in WebAssembly. So now I'm trying to figure out what to do with that. It does open up a few possibilities. The virtual machine itself is a 64-bit virtual machine. The first versions that I wrote were 32-bit, but then Apple decided to impose the restriction for iOS that all iOS applications must be 64-bit if you're going to put them on the App Store. So I converted everything to 64 bits. So now all of my pointers are 64-bit pointers. They are 8-byte aligned, which leaves me 3 bits to record flags for immediate objects. My immediate objects right now are simple. It's small integer character. I have a 32-bit float and one that I use internally called an offset, which is just used for housekeeping. The compiler is a 3-phase recursive descent LL parser, if anyone's into parser theory. It's not a sophisticated parser, but it works. And in fact, as far as I know, most Smalltalk compilers use LL parsers. I separate the parsing into 3 phases. One is the lexical analysis, which is the tokenizer. Then I take the tokens and I parse them into a parse tree. And then I navigate through the parse tree and generate the bytecodes for the code generation. The compiler framework allows you to do trials with backtracking. So you can say, look for this followed by this followed by that. And if it finds this followed by this, but not that, then it backtracks over and tries it with a different pattern. And that's typically how these sorts of LL parsers work. So here's an example that I have. To parse a unary expression, then I need an object first, followed by 1 or more or 0 or more words. So I code that as, I'm going to have a sequence, one thing followed by another. And the sequence is parsing an object followed by 0 or more word tokens. If you get all of those, then produce a result by building the unary message for this rule. And that's what takes the results that are on the stack and builds an object for a unary message. So this is the kind of syntax that I'm using for this parser. I'm considering switching to an LALR parser. And as a beginning step to that, I created a Smalltalk grammar for Bison, which is an open source equivalent of Yak, if you're familiar with Yak, yet another compiler. I created a grammar for Bison, and that gives me all of the tables that you need to create an LALR parser. So in the future, I might write the Smalltalk code to analyze or to run through those tables and do the parsing. And Bison has done the hard work of translating the grammar into the tables. But that's not a pressing project right now. So that's something I'm keeping as a possible to do later. The advantage, though, of an LL parser is that it's much easier for people to look at, to read, and to change. So even though an LALR parser might be more efficient and better at error handling, I think the readability of an LL parser is going to be a determining factor in my decision. In the Smalltalk, I have various object spaces. There's one for new space, which has several spaces for doing generation scavenging. And then currently I have one old space. I might change my mind later and have several. But all of the spaces have their headers at the beginning or at the low part of the memory and their bodies at the top, and they grow toward each other. So even old space, the exception is stack space, which always starts at the top and grows down. But every object will have a header that points to its body, and the last entry in the body is a pointer that points back to the header. And that mechanism just allowed me to easily do things like compaction. How do you compact a space? Well, you go through the bodies in reverse order. And if the object for that body is free, then you copy the next body along, further up in memory. And so long as you're going in the right order, then you can do the compaction. So that worked very well for me. Garbage collection, as I said, is a scavenging Baker's algorithm. And then the old space is mark and sweep with compaction. And I also have a primitive that can reallocate the spaces to be larger or smaller. So if I'm running out of space, I can say reallocate my old space to be bigger, and it'll reallocate it, move all the objects and get me going on the larger space. And that can be done dynamically while you're running. For those who are interested in some details, object headers are 5 entries of 64 bits. I decided in the design of this VM that modern systems have so much memory, I'm not going to worry about using 5 times 64 bits, or I guess 5 times for 20 bytes. No, it's more than that. 5 times whatever. Each one of these is 8 bytes, so 5 times 8 is 40 bytes for a header. But on modern computers, it doesn't really matter that much. And especially for what I'm doing, I can waste some space in the header. The size is a full 64-bit number. The class is a 64-bit pointer to the class. Number of instance vars, I'm restricting it to 65,000 instance variables. If you have more than that, then too bad. I hope you're chuckling at that because I can't hear anybody. Identity hashes are a full 64 bits. It might be a few less because of the flag bits. But body pointers are also a full 64 bits. So all of these things are 64-bit numbers. And I just created as many of them as I needed to get what I felt was a reasonable object header. What do I not have? Large integers with 64-bit small integers. Now, actually, it's more like 61-bit. But do you really need large integers? I know myself, I love showing off various dialects of Smalltalk where I can say, what is 5,000 factorial? And my VM cannot do 5,000 factorial. But realistically, 64-bit integers gives you quite a lot of space to do integers. So for the moment, I'm not in a hurry to implement large integers. I'm not in a hurry to implement fractions, immediate doubles. For some reason, I have not yet had the need to have a sorted collection, so I haven't implemented one yet. And to this point, I haven't had the need for pool variables, which I kind of dislike anyway. but I haven't implemented them yet. I have some support for class variables. And I do have class instance variables. So those are things that I don't have, but until I find that I need the support for them, and I'll probably implement a sorter collection at some point. That one I will need, it's just I haven't needed it yet. So I'm developing things on an as needed basis. So where am I going with this? And where I'm going is, for me, this is a journey of discovery and in some ways sort of a pilgrimage, because I've never yet, like I've been all through the Smalltalk image, but I've never yet written my own Smalltalk. And so this is an experience for me, and I don't know quite where I'd like to go. So let me show you some ideas. I know everybody likes browsers, but I also like an idea that Kent Beck came up with years ago called the Object Explorer, if people remember that. And the Object Explorer let you see an object and then say, click on something, and it opens up another rectangle or another window showing you that thing and connects it with a line. And I could see things with the Object Explorer that I couldn't see any other way. So I'm thinking, what if I had the equivalent of some sort of package? I'm calling it a kit, where I can have a kit for collections, and I open up that, and that has classes. And if I click here, it opens up the dictionary class, and it shows me what the instance variable names are, and the values. This is a little bit off, but I can show the methods. These are the methods of dictionaries. And here, if I click on this, this is the method @put, and it shows me the code for @put. And the things on the left-hand side are different ways of seeing the thing that you're looking at. So default, I just see the source code. If I click on bytecodes, then I can see the bytecode version of all this, the interpreted bytecodes. Evaluate will give me a text area, where I can type code in and have it sent to this object, or object gives me an inspector on the object. And since this is a method, I can go to senders, implementers, or back to the class. So I know this has a lot of windows that open, but it's something I'd like to experiment with to see if I can create, instead of creating a browser, creating an environment that connects objects together, and you can navigate in and make the changes that you need. I just want to see how this sort of system could work. So there's that. The other thing about this is, by having a diagram all the time, you can see where you came from. And it's a little bit hard sometimes with senders and implementers and references to see how you got to here, whereas this picture shows you how you got there. So I kind of like that idea. So I'm not saying this is the best, I'm saying this is an avenue that I want to explore. So where am I going in the end? I would like something where kids can come in and use this as an environment. I'd like to be able to have, let's say, kits for a stage or turtle graphics or pin art, sound, music, ray tracing, graphics, what have you. I can develop the core of the code that goes into these things and give them an environment that they can use to play around and have fun with that kind of kit. If they want to go under the covers and see what's going on, the source code is all available to them, and they can go look. And they can extend it, they can change it, they can do whatever they wish. So this is just an entry, like I give them a starting point and let them explore from there. A stage is something where you have characters who can interact with each other in a little window, and you can script how they interact with each other. So this is a knock knock joke. And the script here is Ruff, which is your dog, enters from the left, Buzz enters from the right. Ruff says, knock, knock, pause for 1 second. Buzz says, who's there? Pause for 1 second, and you can script out a knock, knock joke. And then when you hit play, it plays that, and Ruff will come in, Buzz will come in, Ruff says, knock, knock, and so on. And so this is a form of programming. This notation is intended to be mostly drag and dropped into the script area. I know it looks quite a bit like Scratch. The difference is that all of the source code that builds up, all of the Smalltalk code that underlies all this can be viewed in this script format as well. So if you are comfortable with the script format, then you can look at all the Smalltalk code in script format and make your changes that way. Also, I have the ability to animate the running of the script, so I can highlight Buzz. Now, none of this is written yet. These are my ideas. But highlight Buzz, highlight the word right, and then highlight enter from, and be able to single step through this with some sort of what we know of as a debugger. But I don't think kids would call it a debugger. It would be more like a step-by-step runtime or something. So those are some ideas I have for things I would like to do. Turtle is turtle graphics, so you can draw pictures on the screen using turtles. Pin art is something I used to write up a lot when I was a kid with primitive graphics, is just having points, let's say around a circle or around some shape. And then you say, draw a line from this point to that point with this color. Then draw a line from this point to that point with that color. And it makes these really weird colored patterns. I'd like kids to be able to experiment with sound, be able to create their own waveforms, be able to program a waveform. Things like count from 2 up to 100 by 5s, and that's going to be the amplitude, and then count from 100 down to 2 by 10s, and that's going to be the waveform, and then play that and see what that waveform sounds like. So being able to program sound in some way, to program music, so you can make your own music, have instruments, be able to lay them out in a visual way, or to write scripts to code it in a certain way. So again, these are all ideas of things I would like to do. And as I said, this is a work in progress, but the ultimate intention is to release it as open source, and then to release probably YouTube videos that introduce kids to each one of these and show things that you can do and encourage them to do their own things rather than just being limited to what I tell them to do or what someone else tells them to do. I have a granddaughter and she loves playing on her tablet, and I watch the things on the tablet that she's doing. And what she's doing is always what the developer of that game wants her to do, right? Do this, pretend you're a dentist, and now let's clean the teeth, and now let's do an implant, and you do it this way. And it's entertaining to her, but she's doing what other people are telling her to do. What I want is for kids to be creative and do what they want to do. Hey, I want to do this. Can I do it with that? And have an environment where they can explore that kind of idea. Because for me, the fun part of computing was realizing that I had this superpower where I could do almost anything I wanted to do. And I just had to imagine it and then sit down and write code for it, and it would happen. And that would, for me, was the greatest joy. Some of the questions I anticipate, why don't you just use Scratch? Scratch is wonderful. I love Scratch. What I found with Scratch is a couple of things that I think are not quite optimal. One is I've seen some of the programs kids write with Scratch, and boy, they could use some organization. It's really hard to organize Scratch code. It's very hard to debug Scratch code, from what I've been hearing from people who write Scratch. And Scratch only goes down so far in the levels. You can't see how Scratch is implemented under the covers, and you can't change Scratch in order to make it do what you want it to do that Scratch doesn't already allow you to do. With this system, you have visibility all the way down to the bottom. And in fact, if you want to change the virtual machine, I'll even hand out the VM source code, and you can go with a little bit of trepidation and fear, modify the virtual machine. So those are some things that I'd like to get out of this. For me, this is, like I said, this is a journey I'm on to see what I can do and what works best to help kids explore computing. And with that, I am done that talk, and I am open to questions. So why don't I open it up and let people ask questions, and I'll try to answer. And sorry, I haven't been following the chat. Have you ever seen Self? I'm aware of Self. I've not actually played with Self, but I understand the concepts behind it. Was there sorry, go ahead.
Well, the aesthetic is very similar, and it's just very gratifying to see other work being done from the same set of values. So thank you.
Thank you. Yeah, and Self gave me a lot of ideas and thoughts and inspirations for this. So it was a factor. Someone says 5,000 factorial, not in BA Smalltalk Stack Overflow. Okay, fair enough. I'm trying to catch up on questions. Oh, Stephen Pope, I love Padre. Thank you, Stephen. Oh, and Peter Jones. I guess a lot of people like Padre. I can't really scan through the questions right now. Sorry, I haven't been watching them. Other questions?
I think I've got a comment.
David, I can ask one. Okay, Tim.
Okay, I think Tim asked first. I think if you want to.
I noticed something that someone else said, because I've got a daughter and I watch it with that same stupid dentist game, and yes, it breaks my heart too. So
thank you. I mean, I love the fact that she's using technology and she enjoys it, but it's like, do this. And yeah, that's what they have to do. And it's just mechanical at that point. Now, they might be learning something, but I prefer to encourage the creativity. And thank you for that comment. I didn't know anyone else saw that dentist game. Sorry, what was the next question?
Maybe can I?
Hi, David.
Go on, Bruce.
Really,
I'll step back again. Oh, yeah.
thank you. So I'm Wolfgang from Austria. Hi.
Hi.
Thanks, David, for the talk. It was really, you're having a blast, and I can feel it. It's really great.
That's the intention. If I'm having fun, I hope other people can have fun. And that was the whole idea of DKB Trace and Pavre and So everything I've done basically is to help other people have fun with this stuff. Go ahead.
Great stuff. So what I want to ask is, how do you actually create an image? How do you build that from the source code?
I started off with a program that would build the image for me. And then once the image became sophisticated enough, I threw away the program and used the image to build the image, which means I have lots of backup images in case I screw up.
All right.
It's one of those things, I think I saw it in the original Blue Book, where they said at some point you just have to burn your bridges and throw away the old disk packs and trust that what you have is good enough for you to be able to continue forward.
Mm-hmm.
And so far I've been quite successful at doing that. I'm well past the point where I can rebuild the image from code. I need to use an existing image to build a new image, which is really tricky when you need to make compiler changes.
Indeed.
But I've always found a way to do it. So yeah, that's an excellent question. Thank you. And the VM was also built very slowly from the ground up. Let me start with a push of a small integer. Let's see if that works.
Yeah.
And then just implementing bytecode by bytecode after that. And so yeah, it's just software development can only be done incrementally. And even something as complex as a VM and a Smalltalk image, you can only do it incrementally. I remember learning early on that I could only go so far. Once I had object allocation, then there was a limit to how far I could go until I had some kind of garbage collection. Otherwise, I would just run out of memory. So, and it turns out that the Sea Turtle Rescue game only had a generation scavenger. It never needed mark and sweep because every level basically had its own objects. And when you go and those were all kept in the new space. And when you went to the next level, it would just scavenge all those out, put new objects into the new space, and that's your new level. So I never actually needed to code a mark and sweep. But now I do need it at this level.
Mm-hmm. Well, I can see that it was definitely quite a journey and a lot of hours spent.
Oh, definitely a lot of hours.
Out of it, really, it's great stuff.
Mm-hmm. But being able to get your compiler working and generating bytecodes and saying, that is so cool. That's fun.
So perhaps I could follow on with this question then. So over time, David, how has the percentage of time you spend coding in C versus Smalltalk changed?
Initially, it was almost entirely in C. Nowadays, I rarely touch the C, and I'm coding almost entirely in Smalltalk. So yes, the only time I need to change the C is if I find some sort of bug, which I occasionally still find, and I have to go fix something. Or if I need to port to a new platform, and for some reason there's some quirkiness of that new platform. But for the most part, I don't touch the VM anymore. Let me just check on the VM code and see here. Now, I've been rather busy as of late, so I haven't done much work on this project. But the last time the VM code was changed was in March. So ever since March, I haven't done any VM work. It's all been in the image. And it's all,
so, I've got another one.
Yes.
I've got another question, which is, so you said you referred to developing things on an as needed basis. So yeah. What is your need, David? What drives you along? What's the thing that propels you in a particular direction?
I have my long-term goal, which is what I just showed you. and I keep moving towards that goal. And as I need things to get to that goal, then I write more things for that. So, for instance, sorter collection was just never something that I actually needed. The next thing I want to do in this is to build up that window system a bit more, be able to drag windows around, be able to collapse and close windows, and then start building up that inspector-based, or I'll call it an object explorer-based browser system, so that I can finally code in the environment instead of having to go to text files and edit the text files and file them in. You can't imagine, as a Smalltalk programmer since 1984, how painful it is to edit the text file. Maybe you can understand. Edit the text files and do file in to get your code in. So I want to be able to edit the code in the image. And to do that, I need that kind of browser. So that's where I'm going. And the things that I need to get that done, that's what I'll implement.
So I've got a couple more. So
sure.
On the WASM, when you're running using WASM, can you see into the DOM?
Yes. Because I can call any JavaScript function that I wish, and JavaScript can definitely see into the DOM.
Right. Okay. Super. And the last question is, all those photographs of early computers were very interesting. It was good to see them. Do you have any pictures of you at that time?
Maybe, but I'd have to dig them up. I don't know if I have pictures of me with the computers.
Well, that'd be a good one.
But yeah.
But thank you for the talk, David. It was really brilliant.
Thank you very much. I appreciate it. Other questions?
Yes, I wonder if the stuff you're working on right now would still run, or do you plan to make it run at some point also on Android and iOS, or is a completely different code base, and if so, why that happened?
There should be no reason why I can't run on Android and iOS, especially if I'm running it under a web browser using WebAssembly, right? I mean, with WebAssembly, I can definitely run on iOS and Android. But to run natively, the only thing I would really need to do is to recover some of my old Android code to capture events from the native operating system. There are certain Android things or iOS things that they expect you to implement. The reason that I haven't pushed that right now is that, especially for iOS, in order to keep having a development environment, you have to keep paying Apple each year. And if I don't have a need to deploy to iOS, I don't think I really want to keep paying money to Apple each year to keep up that environment. For Android, it was simply a matter of it's easier to develop on Windows or on Linux or other platforms. So let me just drop Android for now, but there's no reason that I couldn't go back and put in those support again for Android and iOS and get them running there.
Okay, thank you.
I got a question. Have you
Sure.
ever considered releasing Beagle Smalltalk without all of that stuff as just a really bare to the metal run on tiny microcontrollers Smalltalk?
When I release it, it could be used like that. There's really not all that much stuff there to be considered excess baggage. So
Yeah, well, I'm
but yeah.
thinking of running it like on an ESP32 or something like that. Right now we run like MicroPython on that, so I don't see any reason why we couldn't run a micro Smalltalk on it.
Yeah, we might have to tune memory parameters a little bit so that it fits within the memory that you have.
Yeah,
But,
the ESP32 I use has 4 meg of memory, so 4 meg of RAM.
Yeah, it should be feasible, but I haven't considered it per se. The VM right now does allocate a lot of space, just simply so that I don't have to worry about running out. And all of the classes and methods are all, of course, in the Smalltalk image, so it does take a bit of space. But I'm sure it could fit. It could probably fit within 4 meg. I'd have to play with it.
Cool.
I think it's real interesting, the part you brought up about having a non-prescriptive environment for children to work in.
Yeah.
What's one of the things my company is trying to work through is just how to make this kind of thing approachable to normal people, like, tradesmen and garbage collectors and, people who are not thinking of a computer as a machine. It's just, yeah, whatever. And when you look at some of the stuff that's been happening with ChatGPT being applied by kind of everyman, it's interesting the way that they're handling basically capability discovery. So in your case, when you're showing that, the sequencing of windows and that chain of, I'm moving progressively through, that is very, non-deterministic. But have you thought about how to really make it so that it's their own and they understand capabilities and can assemble it in ways you never thought of? I mean, how do you get away from a prescriptive programming metaphor?
A lot of this is going to take other people looking at it besides just myself, because I can't look at it without some kind of bias of knowing how it works. So I'm actually planning to take this to, once I get it developed to a full enough extent, take it to local schools and introduce kids to it and let them try it and watch them and see what they can get, what they can't get, what's easy, what's hard, because I cannot provide that kind of perspective myself. And this is one of the things that was that was detrimental for that Elastilab program that I presented. Once people actually got it, one of the main things was, what do I do? Right? I have a white screen with all sorts of buttons. What do I do? And the first instinct is, I don't know, I'll just close it and go on to something else. So it's challenging to get people to the point where they are interested enough to continue to play with it. So, and as I said, I find that my instincts are totally useless in determining how other people can use it. So I really have to sit down with other people, watch them use it, try not to interrupt too much, and see what they do and how they do it, and then adapt things from there. And that's probably similar to what you have to do in your business.
And a lot of the early Dynabook work was, going along similar paths, but even there, it was being kind of guided in a document-centric kind of a metaphor. And so again, it's that, kind of like Kay talks about the whole, how do you think about things that you've never thought about before? And for a child, or for a person who's just doesn't use computers for anything, but it's like, this could be helpful. It's such a challenging barrier, but I'm thrilled to see, you experimenting in that space. We need a lot more of that.
Oh, thank you. Yeah, no, it's exciting. I'm waiting for the day that I can bring this out to schools and have kids actually try it and see what they do with it. The first few might be a bit frustrating for the kids. We'll see.
Yeah,
but
in our world, we work with the poor and the middle class, and again, it's the same kind of thing. When you go out to somebody and you give them access to something, just seeing how it is so other and so, and it is a great place to be exploring.
As it turns out, one of the contacts I've made here in Ottawa is someone who wants me to go to join him at in a part of town that is more of the poorer, lower class people, where they have kids who really want to learn and really want to do things and don't have the resources to do it. And go down there and set them up with computers and have them learn things and do things. And to me, that sounds very exciting.
And just to put a little spin on that, when you're there, you can interact with their parents and see what their parents do with that. Children have a whole set of their own problems to solve, but the adults that you would get exposure to in that kind of a setting would be seeing it through totally different eyes too.
Yeah, this friend of mine who does this, he'll sometimes bring down 3D printers and show the kids, let's do something on a 3D printer. Or he's also into AI generated art and having them explore that area. So there's just so much that can be done these days. Thank you.
David, have you got any thoughts about persistence, like how people might save things in this kind of system?
Persistence for me is saving an image. I don't want to start working with databases. Thank you very much. And keep in mind, this is for kids to play around with. I don't think I want to have anything that goes outside the Smalltalk image. So if to persist, you save it as an image with a different name, and that's that project. I might have some sort of way of taking a project and writing it out to a file and bringing it back in. But I don't want to get to the point of interfacing with a relational database and in doing selects on rows and so on, in that kind of persistence.
Right, so I think that makes sense. I'm just thinking, like, the thing that all kids want to do is write something and go and show your friends. Like, you want to go to their house and like, here's my thing, and I suppose that means running in the web. So that means, like, how are you going to save your image, right? Well, like, where does it go? One thing I was thinking of was setting up a server, possibly with Docker or something like that, and then having everyone who wants one to be able to sign up for an image in Docker that they can put their code in, that then other people can connect to with their own browsers and use that, so they can share what they did with their friends through the web. Yeah. And that was one thought that I had. Yeah, I think it's an interesting one, because that even today we have that problem. It's just like, even with like the full Smalltalk, the Pharaohs and the Squeaks and everything, some of this kind of persistent stuff and where to host it, and it's still a pain in the butt, isn't it? It's not an easy just click and go kind of thing. Yeah.
So following on from Tim's thing a little bit, are you thinking of having any kind of support for sockets in there, David?
It's WebSockets. So yes.
Okay.
There's a WebSockets implementation in the VM, and I have one in the image as well. So it communicates over WebSockets. So you can have the image running on one system and your whole user interface on a different system. And
Okay.
I've done that. I've had the image running on a Raspberry Pi and then my UI running on a Windows system, and they're connected over WebSockets.
So I could start up a listener on an arbitrary port or
Yes.
make an arbitrary connection to another server somewhere else.
Yes.
Right.
And in theory, I could have multiple user interfaces connected into the same image.
Right.
Right. So
Yep.
Not that I've tried that, but in principle, there's nothing wrong with having multiple user interfaces, which is really bizarre because then different people are editing code in the same image, but from their own, right? From their own browser. So if multiple people can edit code, then you can have one person say, hey, let me go change this. And their friend says, okay, while you're changing that, I'm going to go change this over here. And they're changing it in the same image. That's profound.
That's very croquet-like, isn't it?
Yes, it does sound very croquet-like. You know, people in the same world interacting with what's in that world.
And I guess Jason and co did the Wolfpack programming thing, didn't they? There was a Visual Works thing that they did along the same lines, doing some experiments in that. Yeah, I don't know if people got it, to be honest, but hey, kids are probably better at it. Right?
Who knows?
Sorry, Bruce, it sounded like you were following up with something else.
Oh, I was just going to say that of course, the danger with sockets is it opens you up to all kinds of evils, like even databases.
Yeah. And in fact, some systems don't like you using WebSockets. So yeah, there are some dangers there. I'll have to consider the security aspects of it. But in the end, how much danger is there really if this is all just for fun and you can't do anything beyond this environment? All you can do is destroy your environment. So
right.
I don't know.
I was more thinking of the philosophical danger. You resist the idea of connecting to a database, but once you've got sockets there, of course, some devil will write a database interface.
But that's not my problem anymore, right? Okay. I don't care what people do with it, but don't come to me asking me to support a Postgres database so that you can do something with it. It's like that's antithetical to what I want to do with this. If you want that, go ahead and write your Postgres interface, and all the power to you. And if it's something other people want to use, then share it around. But as a platform, I don't want to have to provide a database interface. That's all. Because that's not the kind of programming, the kind of application I want to get kids excited about.
So just on the how long you think your project is going to be running for, in your bones, when do you think you're going to be making that trek off to the schools?
The problem is lately I've been so busy that it's been very hard to allocate time to this. It's probably still going to be a couple of years. To me, this is what I'm aiming to be sort of a retirement project. When I finally retire and I no longer have to work, I can focus on doing things like the YouTube videos. That's going to take a lot of effort and time to show how to do things in it. And it's going to take a lot of effort. So this could be years in the making, but I'm not in a hurry right now. I'm happy to take my time and take it as I have time to take it. And when I have other priorities, then I just switch to other priorities. So it's been a few months since I've done anything with this system right now, but I hope to get back to it soon once things get a little bit quieter. So like I said, it'll be years, but it's a journey. And I'm having fun, which is important.
That is such an important thing. That's such an important thing. But there's also in there, David, there's the retirement delusion. I've spoken to a great many people who have retired and said, oh yes, when I retire, I've got all this free time. And then when they retire, they find they've got approximately no free time at all.
I think I can relate to that.
Yeah.
Other questions?
I wanted to ask a bit about the graphics, because I think what you showed, which obviously is like the early days, were you just writing directly to a canvas? It was just like drawing on the canvas. You weren't manipulating DOM objects in the browser, like using web components as kind of building blocks. Is that something that you might move to, or?
My focus right now, in order to develop a user interface, is to write to an HTML canvas. Now, do you want to be able to interact with JavaScript and edit the DOM tree and insert grid layout objects with buttons and input fields? That's certainly possible. It's just not where my focus is.
I don't think you have to interact with JavaScript at all. I think you can like actually manipulate. I think the web components piece gives you access to that shadow DOM. I mean, I'm sort of going by what the Code Paradise guys have done. Similar sort of thing, where it's just like, don't want to do any JavaScript. You know, the objects in the DOM are they're exposed as objects. You can just like reference them and use them. Obviously, you can write to them if you want, but it gives you a little bit of a head start. You like, some of the web components are quite nice. They look good, so you can kind of build something quite quickly without having to like have all the basic primitives. I just wonder if it might get you to a place where you can have some richer things to play with without having to implement all of that stuff yourself. That's all.
Possibly, but I think for what I'm aiming for, ultimately I'll need that kind of graphics that I could only create on the canvas.
Yeah.
So if I was aiming Beagle Smalltalk at a more of a market of what Amber Smalltalk hit, then that would be a much different situation. I'd be looking to be able to directly interact with the DOM tree and build up things and take down things from basically be able to write all your JavaScript code in Smalltalk instead.
Yeah.
But for what I'm doing with this project, just being able to draw on a canvas is great. And
will you get a rich enough set of widgets that kids can have a little palette to play with? I mean, I guess the sea turtle thing looked damn good, actually. So is that what you're thinking? Is like, based on that experience, you'll have enough pieces that you get started?
Just a note about Sea Turtle Rescue. I actually had a professional artist animator do all the graphics for it. So that wasn't my work. That was Simon Piquet. He did a great job with it all. Yeah, we put a lot of time and effort into it, but I don't think kids would be programming that kind of game in this. It's possible, but that was a pretty sophisticated game that was just coded directly in Smalltalk. So
I mean, I guess I'm thinking it's like, when you start out, you start with something like enter your name, and you need an input field, a button, maybe you need a little calendar. There's a few kind of basic things that you start with, and then you kind of get to, oh, maybe I want a clock. Okay, well, maybe you draw that one yourself. And I guess if you end up, if it's like so hard to do something that looks good right at the beginning, it hurts, doesn't it? So it's finding that balance, isn't it, of like having something that looks cool, that
right, but
you've got in the palette.
Also consider one of my objectives, which is I want the users of the system to be able to dig down as far as they wish and
Change
see
it,
how
yeah.
things work underneath. And if I bring in a JavaScript clock, then suddenly that code is all JavaScript and you can't see it easily and modify it easily. So by keeping it on a canvas and drawing the clock myself with a circle and little tick marks and whatever, you can go in and find the code for that.
Yeah.
And
So the idea is to have built effectively like a widget system yourself in a way.
yes, yes.
With some nice pieces. Yeah. Okay. No, I mean that that makes sense. Lot to be said for that. By the way, when someone asked about early pictures, I looked over at my bookcase because I've unpacked a whole bunch of boxes, but I haven't unpacked the box with the Carlton yearbook. And I'm wondering, are you in the year? Because you're a few years ahead of me, and I'm just, was he in there? I was going to see, I've got you, but I haven't. So
I would have been in the Carlton yearbook in 1980, 81, and then again in 89, 90.
Because there wasn't one every year for computer science, but yeah, there was one. So
yeah. Willow.
Good morning.
Hi.
So I had a notion when you were talking about your object headers and who cares how big they are. What if you made every object unique identifier a full UUID and gave your Smalltalk the ability to package up stuff and transmit it around, right? So moving processes between Smalltalks is not new, but when you're talking about kids collaborating and you're talking about burning the disk packs and exploring new metaphors, why not just let the computer move programs around and duplicate them to other people's computers so that the kids can actually just make their clock and send it to their friend directly?
You see, that's the Willow I know and love. We have to talk about this. We'll have to have a conversation sometime. That's a neat idea. I like that.
Well, it's just that you've already got a very small Smalltalk, right? So one of the problems with big Smalltalk systems is all the interconnectedness of all the objects gets very big very quickly, right? And if you're starting from such a small code base, a small set of stuff, right, you've got an opportunity to do the kind of explorations that they used to do when they were making Smalltalk from the beginning. I know some of the other programming languages out there that try to do this, they elevate the metaphors. So you won't get the difference between an array or an order collection or a sorted collection. You just have an array that's built into the language. You have a dictionary that's built into the language, linked list or whatever the one we call it, a map, right? So that they have a fixed way of describing this stuff and moving it around between computers. But this, why not just, bloat it up and let everything be uniquely identified so that when I say I want your clock, you can just gather up all the bits and say, here are the bits that are needed. Which of these don't you have? I'll send them to you.
So sort of like one huge image where not everybody has all parts of the image at the same time.
Yeah.
And
I mean, that's the internet, right?
If you don't have it, you just go get it from another computer.
Yeah, and if you have a nice way to serialize it, you know how certain JavaScript libraries are kind of mirrored by Google, so that you can just reference this UUID for various JavaScript libraries. A set of binary, a compacted, garbage collected set of stuff necessary to run the clock can be compressed into a shared library and put up somewhere on the internet so that anybody can reference it without needing another live browser. So you could then jump into the whole peer-to-peer knowledge sort of stuff and say, I need this component. Does anybody connected to the internet have this? Or you could go down that route of, oh, no, it's just on this server. Here's the URL.
Food for thought. I like it. Thank you. Yeah, we should talk about it sometime when it's not 4 o'clock in the morning your time, Willow.
It's now 5:45 a.m. So,
Hey,
getting there.
There you go. Thank you. Other questions? I think I'm done.
Did you ever take a look at the work done by Feline Hermans on Hades, on a programming language to learn programming?
No, I haven't seen that. So what is this?
Well, she started teaching kids with Python, and then noticed that as a way to teach people how to program, that is not very optimal. So what she did is she made several generations of language grammars, and starting with a very simple one to help solve easy problems for the kids, and then gradually builds up the language. And she has been doing very interesting stuff with that. Also having that available in all different kinds of languages, and yeah, being aware of all kinds of problems with accessibility for programming.
Send me a reference to it if you could.
Yeah.
David@Simbaron.com.
Yep.
Appreciate it. Thank you.
Yeah.
Okay, shall I hand it back to Giovanni and to wrap up?
Yeah, let's see. I don't know. He might have had to step out. He didn't mention to me because I know sometimes he has to go and do the baby thing. Anyway, I'll type up for him. Thank you, David. Really appreciate you taking the time to talk to us. We shall look forward to the continuing involvement of Beagle and where you get up to. I mean, if people want to follow your progress, are you you used to have a blog post, didn't you? Do you still blog every once in a while, or?
It's been a while. I should try and update it and put up something. Oh, and incidentally, at one point I was calling it Pigeon Smalltalk instead of Beagle.
That's right, yeah.
The reason for Pigeon was that I wanted to animate the message sends by carrier pigeon. And so when you get to a certain point and you want to send a message, you send out a carrier pigeon, which flies off somewhere else, and it'll animate it and show it processing, and the carrier pigeon comes back with the answer. So I was calling it Pigeon Smalltalk. And then I got some responses from France, from some French people there who said, please don't call it Pigeon Smalltalk. Pigeon is, in French, it's a derogatory term. And we really take offense at the word pigeon. So I thought hard about it, and I chose Beagle because Beagle was the name of the ship that Charles Darwin was on when he made his voyage of discovery. And that's what this really is a voyage of discovery. And it gives me the opportunity to have a cute little logo.
Yeah, nice. So yeah, no, I encourage you to post some updates somewhere so we can all follow along.
Will do.
My batteries have run out on my headphones. Yeah, so people can look out for that. Obviously, Giovanni said he's got this backlog of recordings, so it might be a couple of months before this one actually goes live. If you're at Camp Smalltalk with him, maybe you can sit and anyone that's there, try and help him get more of these kind of things coded up and put up, because I know they're quite nice for people to see afterwards. But yeah, anyway, thanks a lot, David. I'm going to grab a beer and hang out for a little bit longer. So anyone who wants to stay. Sometimes there's sort of the after party chat for people to talk about what David has shown us. By all means, David, hang out if you want to, but I also understand that, it's different time zones for different people. I'm quite impressed that Willow was up at, I don't know,